Hello again, you sick, twisted weather freaks. Welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT from WX Risk here in Central Virginia. The commander of chaos, the colonel of confusion, the captain of catastrophe. Let's talk about weather, which obviously is the best topic in the whole world to talk about. So let's get right to it. First, I'll point out there's my Twitter page. You want to follow me? There you go. This here is the actually that's the Twitter page. Sorry, that's a picture of my smiling face from Richmond, Virginia. There I am. And again, that's the Twitter page. And then of course here's the snowstorm page, which gets updated every few days. A new update coming out tomorrow morning. So look for that. And our topics here will be, of course, talking about the huge, big ocean lows, which are going on in the North Atlantic and the teleconnections, why these lows are bombing out in the North Atlantic like they are. We'll talk about a potential snow threat, maybe February 21 for the southern half of Virginia, North Carolina, maybe. And then what's going to happen after that. So let's get right to it. First, we're going to take a look here at these recent trends. This year is the Arctic Oscillation, and you can see that let me get my marker out. You can see it now. This course is from November 1st. So notice here then when it was negative, that's when we were cold in November. We actually had some snow on the East Coast in a couple of these different events. You see that? And then look what happened. Then it oscillated back and forth in December, but we are still pretty warm. And then really, since January 1st, it has been way up here. And this is the peak right up in here, right before. And that's one of the reasons why we had these monster storms, which developed right along in here, the big low pressure area. So the Arctic Oscillation has clearly had a big impact on the big storms in the North Atlantic. Not so much for the East Coast, except for the East Coast, it's just been blowtorch after blowtorch after blowtorch weather pattern and very little sustained actual snowfall. This is the North Atlantic Oscillation, same sort of thing. Again, notice in November, back in here, it was when it's kind of negative at times, we were sort of cold, and then since then it's been persistently either neutral a few times and then positive. Not as strong as the Arctic Oscillation. And clearly what's happening here is when you have a strong positive Arctic Oscillation like this, when it's massive on top of the North Pole, and it has a lot of intensity to it, it has a lot of height lines around it, like a low pressure area at the surface. We're used to a coastal low. You see a hurricane has a lot of wind with it. There's a lot of isobars around it. Sea level pressure. Well, when you have an upper level low, it has height lines over it, and when you have a lot of height lines, you have a lot of wind, just like at the surface. And when you have a huge Arctic Oscillation, you have a lot of strong winds and very strong jet streams. And this is the one example of that. So we can see here, this is from back on the 14th. The model is showing, and only 18 hours out, you can see an enormous jet streak here. If you look at the white color right in here, of 180, 190 knots, which is well over 200 miles an hour. So when that's hitting low pressure areas, which are tracking across the Atlantic Ocean like this, just ho-hum going along the way, they hit that jet streak and they go kablooey and they become monster storms. And that's what's been going on here. If we take a look at the this here and we go beyond this, let me clear that out. This is the PNA, the Pacific North America pattern. This is the West Coast ridge. In Canada, we talk about that. Getting your ridge on the West Coast allows you to bring the cold air into the central and eastern U.S. Well, as you can see, the PNA's been back and forth, up and down, no real steady pattern. So it's not been very strong. You notice it's not got not a lot of amplitude here. Almost everything on the PNA since November 1st is in between -1 and +1. So a very narrow range, and it's down, and it's up, and it's down, and it's up. It's not doing a whole lot. Okay. Then, of course, we look at the EPO, which is the Eastern Pacific Oscillation. This is your Alaska ridge. So sometimes when the ridge on the West Coast will extend up into Alaska and the Arctic region, pulling down the cold air. And again, you want this to be negative if you like winter weather over the eastern United States. And as you can see, back in November, we were fairly negative. In October, we could see all the way up to here. And then it shifted and started going positive, and now it's been very positive ever since. Few brief, weak negative intervals, but that's been about it. So it also has not been, it's been a pretty strong feature, and it's been in the wrong phase completely. Now this here is the current MJO. Now let's take a look at this, the Matty-Lin Oscillation. So you can see where it is right here. It is, as you can see on the 15th, right there. In phase 6 of moderate intensity, but clearly very noticeable there in phase 6. Now, if you look at what that typically means in the month of February, this you're going to love this. This is just so cool. Now, watch this, folks. Just pay attention here, okay? We have this our negative trough right here. We have a ridge over the southeast, which we've had, and look at the negative anomaly in the North Atlantic, favoring monster storms in the North Atlantic. So it's not just the jet stream. Obviously, it's been a part of it. It's also the fact that when the MJO is in phase 6, it's a huge negative anomaly in the North Atlantic. So I think that's what's really significant. And if we compare that to the current actual upper air pattern, we can see, hang on one second. If we, like I said, if we compare this tendency with the MJO phase 6 to what the actual pattern is. Now this is tilted a little bit, but you can see that it clearly matches the MJO very nicely with the anomalies. This is 500 millibars. You can clearly see that. So I think it's a really useful tool. I think this is just a perfect match for what's going on in the hemisphere right now in the MJO. Now let's take a look at these storms here. Now this is from on the 14th in the North Atlantic. So here we have this monster low. This is just one of them right now. This is like the second or third one they've had here. Look how monstrously powerful this system is. This is on, again, early on the morning of the 14th. Look at that, 929 millibars south of Iceland. That is the tip of Greenland right here, in case you can't see it. But look at that monster. That's like a Category 4 hurricane. Now, it begins to evolve. Okay, it begins to occlude, I should say. You can see the occlusion developing here. Okay, so the cold air wraps up, overtakes the warm air. Here's the warm air trying to come up, so the cold air cuts it off. Now the whole system occludes and then begins to rotate back to the west. You can see 933 and another list of 941 here, rotating this way. But look, there's another low which is forming, which has come off the coast of Halifax, Nova Scotia. And now look what happens. This is so cool. It begins to really bomb out, 956 millibars. This is now the afternoon of the 14th. Look at this. Here it is, 956 bombing out. The other two lows are now here stationary, and one is being absorbed by the other one. And then we get to early on the 15th here, late on the night of the 14th. This system, which started out 972, is now, look at this, 944. It hits that jet stream, it goes bam! It just explodes when it hits that jet stream energy. And then the other two lows are coming down around it. So what's happening is we're getting Fujiwara, which is one of the greatest things in all of weather today in the history of mankind. Fujiwara effect. This system is dropping down, and this one is wrapping up into it, and it's just going to become a gargantuan system. I just love Fujiwaras when they happen. They don't happen very often, but in the North Atlantic, sometimes in the right pattern, these things can go kablooey. Now look at this. This is now early in the morning of the 15th, right? Just going to love this. 936 here, 933 there. Almost equal intensity here, equidistance apart. There's a midway point right here. This is rotating this way. This is rotating this way. Oh my God, it's just the greatest thing ever. And then finally, this here on the mid-morning, midday on the 15th, you can see here, the one low is coming in this way, and this low is this way, 925 millibars. Remember, this one right here started out only a few hours, 36 hours ago, at 972. Now it's 929, 926. Unfreaking believable. Just one of the great things. And then here, finally, we can see this is now later on the 15th. We have two lows becoming one big system, 920 millibars, so off the southern tip of Iceland. It finally fills, reaching its maximum intensity, 922 right here, the second strongest in the North Atlantic since we've been keeping weather records. And the other thing is, look, all this time, look what this is doing. You're getting all this wind driving all this massive amount of water. Look at these howling winds here. Storm force winds, even though it's not hurricane force, still 50, 60, 70 mile winds for hundreds of miles in the Atlantic, driving the water into Ireland and Wales and Scotland, west coast of Scotland, England. Look at this, just flooding this monster fetch of high, very strong winds, driving that water in. Just unbelievable. And of course, in case you don't know this was the biggest storm severe weather day, yesterday was, in the history of the United Kingdom. The Met Office has been doing that. I think over 500 different warnings issued, flood warnings, high wind warnings, storm warnings, everything. And this final, I think, is the latest image. There it is now north of Scotland, 946. Very intense cyclone. So we used to track these things when I was in the Navy in Scotland at a Holy Lock. Just unbelievable there. So I really love North Atlantic weather when it bombs out like this. Gets me very excited. This is the, you can probably tell, this is just typical of the flooding here. This was in Wales. You can see this is what it looks like regular down here. This is a regular, and then this is current right now or yesterday. You can see that. Just unbelievable. So it's pretty significant. Okay. I got that out of my system. I just had to talk about that. I'm sorry, I just had to. Okay. Closer to home, these are the temperature anomalies for the past 2 months since mid-December. You can see here, lower left, this is the East Coast, but really in the upper right, it's really the whole country, especially east of the Rockies. I mean, it's been a warm winter everywhere. So, I don't know if this is going to go into the record books as one of the warmest winters ever, but it could be in the top five for a lot of places. It's been pretty tough. Okay. That being said, a couple of days ago here, this was back on February 13th, the European model is showing a snowstorm developing the Carolinas and the southeast third of Virginia into the Delmarva, maybe southern New Jersey. And you can see this is what it was doing here. And this is valid for the 22nd. Now, this is for Saturday, February 22nd. So that, of course, but this is, way out there. This is 228 hours, 240 hours out from the 13th, which was last Thursday. So, but just to give you an idea of what it was showing, and the snow amounts people were getting excited about was this sort of thing. Look at that. I mean, 20 inches in eastern North Carolina. Are you kidding me? Wow. And the reason why he was doing that was because of this. So what happens is the model develops a strong piece of energy. One piece comes down from here, and the other piece is here, and they phase, so you end up getting a closed upper low. You see this? A closed upper low here. And what happens is it gets a line. There's the upper low. You can see it. Let me draw the line in. So you see the trough axis. It goes from eastern Kentucky down to Texas. You see that? So when it's like this, okay, that's positively tilted, right? And what happens is it's going to swing around and become neutral or negative tilted by the time it gets to North Carolina. That's how the model was developing the big snowstorm. Let me show you. Okay. Here we go. Now, this is the image on the left is what we just looked at. Now, look what happens by the time we get to February 22nd. You see how the upper low swings around and goes over the Carolinas and southern Virginia and then over Cape Hatteras? That's how you get your monster snowstorm if that were to happen. If that were to happen. If. Okay? So, now, this is a very unusual scenario, but it does happen from time to time. And notice the system in this sort of pattern has no chance of coming up the coast. You can see that the winds are howling right across U.S. North Canada border, so there's no chance of the phasing and coming up the coast. This is completely, if it were to happen, a southern system and not impacting the northern Mid-Atlantic or New England at all. This here is... now, the GFS model has hinted at a little bit. This was the GFS model from Friday. And you can see that it kind of had a little system there with some snow in North Carolina and a weak low off the coast. But the GFS does not handle southern systems really well. We all know that. It has a problem with southern stream energy. So it's not a surprise that the GFS is not handling it well. Now, the reason for that is this. Let me show you what the GFS is doing. So here is the big piece of energy. We have two pieces that have to watch. This piece right here. See how this piece? And then this piece. These two pieces, these two pieces have to phase and become a big upper low here. Okay, but what happens is this piece gets left behind and this piece comes by itself, and you end up with an ordinary trough which doesn't do anything. Let me show you. This is what the GFS was doing back on the 15th of February, which was Friday night. Notice this, that piece of energy out here stays out here. See that? It doesn't come in. And then you have your trough here and a little weak area of low pressure way off the coast, which goes out to sea. That's what the GFS is doing. Now, interestingly enough, the new run of the GFS, this is now, look at the date here. Let me highlight the date here so you can see it. This is brand new. This is Monday, Sunday night, Monday morning. Okay, notice that little piece of energy is now here. And you have the other piece there. Now, this is very different from that or this. Look at the difference between, this was back on the February 15th, the night of the 14th, Friday night. compared to this. Friday night compared to this. So this is more promising, but still, even though the GFS has that second piece of energy coming east out of the Rockies, the model still does this. Nothing. It just has a flat wave moving off the coast. Okay, well, that's the GFS for you. Now, here's the European model from this Sunday afternoon. And again, there's one piece of energy here, and look at the second piece there. Those two pieces have to come out together to get the big snowstorm. If only one piece comes out, it's a weak wave. It does a little bit of snow and it goes off the coast. So that's what it is. Both pieces together. That's what we need. Now, let's see what happens. As you can see, the European model doesn't do that. That piece of energy breaks up. One piece hangs here, a little piece here, another piece here. So it kind of comes out together, but kind of doesn't. And it doesn't really do much. And as you can see, we get to with Wednesday night, early Thursday morning, the main piece of energy is still back here. See that? That's not what you wanted to see at all. So there's the other piece. The two things are separate, and it doesn't do anything. So you don't get a big system on the operational European. And then finally, if we go to here, you can see the system moving off the South Carolina coast and out to sea. And this sort of pattern, it can't come to the north, it can't turn the corner. You may get snow into southern Virginia, maybe, North Carolina, maybe, and then it goes out to sea. Not a big deal. And you can see that here. Now the European ensemble is doing something a little differently. It has a little bit system, a little stronger, a little closer to the coast, and you can see it's got a little bit of snow in this area here. I mean, it's not a lot, it's a little bit. And if we enlarge it on the ensemble, you can see it here. This is Thursday night into Friday morning, not Saturday, Thursday night into Friday morning. Same thing here. You can see, again, the snow band, it's very light. It's not a big deal. Okay. It goes up to maybe Roanoke, maybe to DC for an hour, a couple hours. And then, early Friday morning, it's still Charlottesville, Fredericksburg, St. Mary's, maybe Farmville, Lynchburg. That's about it. And then boom, it's gone. And the only thing it does is this. I mean, you're talking half inch to an inch of snow, by Friday morning. It's nothing. It doesn't do anything. If we look at the ensembles, you can see that there is an increasing trend a little bit. This is the GFS ensemble, and this is for Raleigh, as you can see, North Carolina. And several of the models are showing some sort of snow event, really light stuff right here on the 21st and the 22nd. Not a big deal, but it's there. This is the Canadian model. Again, the same sort of thing. It's got something, half inch to an inch right here. Not a big deal. 21, something like that. And then finally, you can also see that on the European as well, doing the same sort of thing for Raleigh. Southeast Virginia is almost the same thing. Gets about an inch of snow in the mean, maybe. Okay. Now, once that system goes on through, let's assume all that happens, right? And what happens after that? So let's take a look at the next weekend. So we have one system is here, is the things moving off the coast. Now look at the polar vortex in the Gulf of Alaska. This is the kiss of death for winter weather over the eastern half of the country. And what's going to happen is it drives the Pacific jet, this huge trough here, upper low here, and you have your ridge here. So the lines get very compacted here. You get a very strong jet which slams into the west coast and sets up another trough over the Rockies and the Plain States. You can see it here. This is February 25. Big, huge upper low over the Rockies. Major snowstorm coming for, if this is right, for portions of Nevada, Utah, Colorado, Wyoming. Big snowstorm coming here. The Western Plains as well, if this is right. Over the East Coast, it's warm, it's wet. Well, it's warm and it's dry, but it will be wet. This is all warm and dry, but that low, as you can see, is clearly going to go in this direction. So it's going to bring rain and more mild temperatures, and you can see it actually does that. There you go. It goes here. Sorry, excuse me. There it is in the upper Midwest, and then here it is over New England. And then some cold air comes in behind it by February 28th, 29th for a couple of days. That's the end of February. Not with big whoop-de-doo. All that being said, let's go over this one. There is something here which is kind of interesting. This here, again, we talked about the MJO. There it is in phase 6. You can clearly see it. The Australian model and the GFS are taking the MJO into phase 8. You can see it right there. Into phase 8. See it is, see the green line getting in there? Gets into phase 8. Now the European model is not doing that yet, but these two models are, and the Australians are pretty good. The reason why that's important is because this is what it looks like. We are in phase 8 in the month of March. It favors its very strong Arctic oscillation and negative oscillation being negative. You can see that. Okay, that would be a big flip, and it has a huge negative anomaly off the east coast, on the east coast, for indicating a potential big winter storm. That's what the pattern favors in March when it goes into phase 8, and this is what it does in phase 1. If it were to go into phase 1, same sort of thing. Very strong stormy pattern here if it actually happens. The problem is if we look at the extended EPS and teleconnections here, we see no hint of that on any of this stuff. So this is an interesting clash to see which one's going to be right. This is the European 45-day EPS from last week, last Friday. You can see strongly positive, record positive here, record positive here. Then it drops down, but it's still consistently positive right through until the middle of March. This is the NAO here. You can see again positive spike, drops down to near neutral, but that's we've seen that already many times this winter where the NAO has been near neutral. And then if you look at the the Pacific side, the PNA is consistently negative, which means a trough on the west coast, no ridging there. And the EPO in the bottom right, again, strongly positive, goes to neutral, not a big deal. So this all means that this and these are not in agreement. So again, it's just a possibility that maybe there might be reason to think something might happen in March. But again, we have to get the MJO here into phase 8. Maybe these models are wrong. Maybe the MJO doesn't go into phase 8. We'll see. And if it does, maybe that might cause these teleconnections to change, because right now these teleconnections for winter weather over the eastern half of the country suck. I mean, they're bad. So that's where we stand. This is meteorologist DT from Weather Risk. I'll talk to you soon. I will see you on the Facebook page, on the website, and on the Twitter page.